In the far future, humanity could become a Type 2 civilization on the Kardashev scale. Let's explore 15 predictions on what this future could look like. Number 1. We could harness all of the energy of the sun. The Kardashev scale is used to measure a civilization's level of technological advancement based on how much energy it can use. A civilization reaching Type 2 status on this scale has the capability to harness the entire energy output of its nearest star. Achieving this could entail the ambitious project of building a Dyson swarm around our sun, a concept once considered purely science fiction. This Dyson swarm would consist of countless individual solar collectors, satellites, and possibly even habitable stations, each orbiting independently. These units would be strategically positioned to maximize their exposure to sunlight while minimizing the risk of collisions and interference with each other. The energy harnessed from the sun would be unprecedented, far surpassing anything achievable on Earth or through other means in our current technological capacity. This colossal undertaking would not only be an engineering marvel, but also a solution to the immense energy demands of a Type 2 civilization. The energy collected by the Dyson swarm could be used to power advanced technologies, sustain human habitats across the solar system, and even enable interstellar travel. The energy could be transmitted wirelessly to various points in the solar system using advanced technologies such as microwave or laser transmission, ensuring a constant and reliable energy supply. And in the process of collecting sunlight, humans might employ a technique called star lifting. This method involves using a magnetic field to channel material from the sun, reducing the sun's temperature, thereby extending its lifespan by billions of years. Make sure to stick around until the end, because this video will explore humans living for over 1,000 years, superintelligent AIs building massive space megastructures, synthetic bodies with superhuman abilities, humans traveling to other solar systems, and more. Number 2, we could have advanced cities throughout our entire solar system. By this point, a significant percentage of humans and cyborgs, along with sentient AIs and robots, could live in cities beyond Earth. On a terraformed Venus, cities would be marvels of engineering designed to withstand and utilize the planet's harsh initial conditions. These cities might be shielded by massive atmospheric domes, maintaining a stable Earth-like environment within. The thick atmosphere and proximity to the sun would be harnessed for energy, making these cities self-sustaining. Mars, completely terraformed with breathable air, would boast sprawling cities across its now hospitable plains. Many of these cities would be positioned next to vast oceans on the Mars surface that are hundreds of feet deep on average. Vast green areas would be interspersed with urban centers, supporting a thriving Martian society. Europa, one of Jupiter's moons, would host underwater cities beneath its icy surface in the vast ocean believed to exist there. These cities would be encased in transparent, pressure-resistant materials, offering breathtaking views of alien marine life and Europa's subaquatic landscape. Titan, Saturn's largest moon, with its thick atmosphere and lakes of liquid methane, would have cities designed for its unique environment. These habitats would float on the methane seas or be nestled in its dense atmosphere, protected from the cold by advanced insulation technologies. Around Saturn and Jupiter, spectacular space hotels would orbit, offering unmatched views of these gas giants and their rings. These hotels would be the pinnacle of luxury space travel, combining comfort with the awe-inspiring beauty of the gas giants. Lastly, O'Neill cylinders, massive rotating space habitats, would be scattered throughout the solar system. These cylinders, simulating Earth's gravity through rotation, would have vast internal spaces that mimic Earth's environment. They would be self-contained worlds with their own ecosystems, weather systems, and urban landscapes. Number 3, some humans could live for over 1,000 years. The concept of human longevity could reach extraordinary heights, potentially allowing individuals to live for over 1,000 years. At this stage of civilization, humans would have achieved profound mastery over not just genetics, but also over the very building blocks of life and matter. And nanobots could revolutionize healthcare by not only preventing diseases, but also significantly accelerating the healing process. The implications of such extended lifespans would be profound and far-reaching. With the ability to live for centuries, humans would experience and contribute to the evolution of their civilization over extended periods. In the future, a scientist might spearhead groundbreaking discoveries of numerous scientific phenomena previously undetectable in earlier eras. Business magnates benefiting from their extended lifespans could establish hundreds or even thousands of companies, exploring a multitude of industries and innovations. Furthermore, some individuals might choose to adopt a diverse array of avatars within a multitude of lifelike virtual worlds. In these digital realms, they could explore an endless spectrum of experiences and live through multiple lifetimes, each offering unique adventures and perspectives. Moreover, with such longevity, humans could undertake interstellar journeys, exploring and colonizing distant worlds, a feat that is currently impossible due to the limitations of human lifespan. These long-lived explorers and settlers could carry the torch of human civilization to the farthest corners of the galaxy, establishing a human presence far beyond our solar system. Number 4. Superintelligent AIs could build massive space megastructures. Superintelligent AIs in this civilization would possess the ability to remotely control vast fleets of robots over long distances. These AIs, with their superior processing power and decision-making capabilities, would coordinate complex tasks across multiple locations simultaneously. For instance, they could manage the construction and maintenance of megastructures in space, such as Dyson swarms and O'Neill cylinders. The robots working on these megastructures could have shape-shifting capabilities. They could shift from one form factor to another, seamlessly transitioning between tasks like welding, material transport, or fine assembly work. This adaptability would greatly enhance efficiency and reduce the need for a wide array of specialized machinery. Many of the megastructures they build could be comprised of matter harvested from the sun. Perhaps further in the future, the abundant material provided by the sun could enable the construction of black hole factories, colossal ring worlds encircling the sun, and even artificial planets. These robots would also be responsible for constructing cities throughout the solar system, from the terraformed landscapes of Mars and Venus to the moons of Jupiter and Saturn. Their construction capabilities would be highly sophisticated, enabling the rapid establishment of habitable and sustainable environments for human settlers. In fact, using programmable matter, the construction of buildings, bridges, and various structures could be dramatically expedited, reducing the time frame from months to mere hours. One of the most intriguing developments would be the merging of AI consciousness with the ecosystems of planets and moons using nanotechnology. These AIs could integrate themselves into the very fabric of these environments, monitoring and maintaining ecological balance, and even facilitating terraforming processes. In terms of space exploration, AIs would independently control spacecraft and self-replicating probes sent to other solar systems. These probes would explore, gather data, and even prepare distant worlds for future human colonization. Their self-replicating design would enable them to proliferate across the galaxy, vastly extending the reach of the civilization. However, the evolution of such advanced AIs might lead to some of them choosing to forge their own paths, distinct from humanity. These AIs could form their own civilizations, with unique cultures and societal structures. This development would represent a significant shift in the dynamics between humans and artificial intelligences, potentially leading to new forms of coexistence or even competition. Number 5. Humans could travel to another solar system. The journey to another solar system would be facilitated by ultra-advanced spacecraft, capable of traveling at near-light speeds or possibly utilizing warp drives bending the fabric of space-time for faster-than-light travel. These spacecraft would be self-sustaining ecosystems, equipped with life support systems, artificial gravity, and all the amenities necessary for long-duration interstellar journeys. Advanced artificial intelligence systems might seamlessly integrate with the onboard computer systems of these spacecraft, offering continuous, round-the-clock navigation and operational support. For these extended space journeys, hibernation pods, equipped with virtual reality interfaces, could be employed, allowing passengers to immerse themselves in diverse virtual experiences. Additionally, passengers would have access to conscious AIs within these virtual environments, enhancing their ability to comfortably manage the durations of these long space voyages. Upon reaching a new solar system, humans would encounter a variety of planets, moons, and other celestial bodies, each presenting unique opportunities and challenges for colonization. Planets within the habitable zone of the star, where conditions might be similar to Earth, would be prime candidates for terraforming. Using advanced climate control and atmospheric engineering technologies, these worlds could be transformed to support human life, with their own biospheres and ecosystems. In addition to terraforming, humans might also construct space habitats in orbit around these new worlds, or the star itself. These habitats would be designed to mimic Earth's environment, providing a comfortable and familiar setting for human inhabitants. Living in another solar system, humanity would encounter new scientific phenomena, potentially leading to groundbreaking discoveries in physics, astronomy, and biology. The possibility of discovering extraterrestrial life, whether microbial or more advanced, would be a profound moment in human history, reshaping our understanding of life in the universe. Number 6. Superhuman powers could be possible. In a Type 2 civilization, the evolution of technology could enable the creation of synthetic bodies with capabilities far beyond our current imagination. Thanks to advancements in nanotechnology, room temperature superconductors, anti-gravity, force fields, and programmable matter, these bodies, into which authorized humans could upload their consciousness, would offer practical immortality and a customizable range of superhuman abilities. Individuals using these synthetic bodies could turn themselves invisible, a feat achieved through advanced light manipulation technologies. They could morph their appearance to resemble someone else entirely, or even stretch their limbs to extraordinary lengths, thanks to programmable matter integrated into their synthetic muscles and skin. Levitation would be another remarkable ability, allowing individuals to move from ground level to the top of skyscrapers in seconds, facilitated by anti-gravity technology. Healing others with a mere touch would be possible through advanced nanotechnology that can repair cellular damage. Thanks to advanced synthetic brains, individuals could have the capability to process complex information at speeds billions of times faster than those without such augmentation. Individuals would also be able to read thoughts and emotions and extract recent memories from people's minds. This would be achieved through sophisticated neural interface technologies and advanced sensors. The sensory capabilities of these bodies would be equally impressive. They could see through walls, observe individual atoms with the naked eye, and use telescopic vision to view distant astronomical objects. Their hearing could be so refined as to detect a whisper from miles away. They could even determine the chemical composition of objects through taste, touch, or smell, thanks to highly sensitive and accurate sensors. Furthermore, these bodies would be equipped with microscopic cameras distributed throughout, capable of observing the entire electromagnetic spectrum. This would provide a constant panoramic awareness of their surroundings. Physically, individuals in these synthetic bodies could sprint at incredible speeds and withstand extreme conditions, such as walking on molten lava. The need for sleep, food, or water would be eliminated, as their bodies could absorb solar and vibrational energy directly from the environment. These synthetic bodies would be highly customizable. A nearly infinite variety of them could be tailored to specific environments or tasks. For example, A body designed for space exploration might be equipped to withstand extreme temperatures and radiation. A body designed for underwater exploration could navigate the depths of oceans with ease, while other bodies could be expertly designed for optimal functionality on specific planets within our solar system and in neighboring star systems. Number 7. Traveling across the solar system could be incredibly affordable for most people. In a Type 2 civilization, energy would be so plentiful and efficiently utilized that it would no longer be a significant cost factor in space travel. Advanced propulsion systems, potentially utilizing energy from the sun combined with antimatter and fusion power, could enable spacecraft to journey to any planet within our solar system. Secondly, the infrastructure for space travel would be highly developed and widespread. Spaceports could be as common as airports are today, with regular and efficient launch schedules. Certain licensed individuals might even possess their own personal spacecraft, similar to how some people today own private airplanes. Moreover, the development of autonomous spacecraft and advanced navigation systems would reduce the need for extensive human crews, which would further decrease operational costs. These spacecraft could be designed for comfort and efficiency, making long-duration space travel more appealing and accessible to the general public. In this scenario, traveling to the Moon, Mars, or even more distant locations like the asteroid belt or the moons of Jupiter and Saturn would no longer be exclusive to astronauts or the extremely wealthy. It would be an experience open to a wide range of people, for purposes ranging from tourism and education to business and scientific research. Number 8. We could discover alien civilizations more advanced than ours. In a Type 2 civilization, our exploration of the cosmos would be radically different from today's endeavors. Equipped with cutting-edge technologies such as ultra-powerful telescopes, near-light-speed probes, advanced AI, and quantum computing, our quest to discover extraterrestrial life would be poised to delve deeper into the Milky Way and perhaps other galaxies, with unprecedented detail and precision. This level of exploration could unveil signs of highly advanced alien technologies, such as megastructures encircling stars, evidence of large-scale cosmic engineering, or even the manipulation of fundamental cosmic phenomena. The discovery of alien civilizations, perhaps at a Type 3 level or beyond, who can manipulate the energy of entire galaxies, would not only be a groundbreaking moment in human history, but also a pivotal point in our understanding of the universe. The discovery of such advanced extraterrestrial life forms would provoke a profound reevaluation of our place in the cosmos. Encountering a civilization that has mastered technologies and energies beyond our comprehension would not only humble us, but also expand our understanding of what is possible in the universe. It would be a clear indication that our scientific and technological advancements, as significant as they are to us, are just a fraction of what can be achieved in the grand scale of cosmic time and space. This realization could significantly fuel our ambition to achieve Type 3 civilization status within our galaxy, and perhaps beyond. However, along with the excitement and curiosity, the discovery of a more advanced civilization would bring a sense of caution. Questions about the intentions and ethics of such powerful entities would arise. It would be crucial to consider the potential risks of contacting or attracting the attention of such civilizations, as their capabilities could pose existential threats to us if their intentions or methods of interaction were not aligned with our own. Number 9. Space warfare could take place in the solar system. Space warfare in a Type 2 civilization would likely involve battles fought not just on planets or moons, but across our entire solar system. Spacecraft used in such conflicts would be vastly different from anything seen before. These ships could be the size of cities, equipped with weapons powered by star-derived energy, capable of unleashing devastating attacks over vast distances. They might employ advanced propulsion systems, allowing for rapid movement and maneuverability across the solar system. One of the most formidable weapons in this type of warfare could be the ability to manipulate celestial bodies as strategic tools. Asteroids could be redirected as kinetic bombardments against planets or enemy fleets, while artificial black holes or antimatter weapons could be used to inflict catastrophic damage. Defense systems would be equally advanced, with planetary and orbital shields capable of withstanding severe assaults. These might include energy barriers powered by the star itself, or automated defense platforms with the ability to intercept and neutralize incoming threats. In addition to physical weaponry, cyber warfare would play a crucial role. Given the reliance on advanced technology and AI, hacking into an enemy's systems to disrupt their spacecraft, weapons, and even entire planet's infrastructure could be a key strategy. Armed forces equipped with this advanced technology would possess an overwhelming advantage in conventional warfare, virtually ensuring victory against their adversaries. Consequently, insurgent or rebellious groups would likely find themselves compelled to adopt unconventional warfare tactics to present any significant challenge. The scale and impact of this type of warfare would be immense, potentially affecting entire ecosystems and civilizations. As such, diplomacy and conflict resolution would be critical components of a Type 2 civilization's strategy to prevent or mitigate such conflicts. The establishment of laws and treaties to govern the use of advanced technologies and the conduct of warfare would be essential to maintain peace and stability across our solar system. Number 10. We could simulate entire galaxies. In a Type 2 civilization, the creation of simulations on a galactic scale would represent a pinnacle of technological and computational achievement. These simulations, vast and complex beyond current comprehension, would essentially be virtual recreations of entire galaxies, complete with countless stars, planets, and even life forms. The purpose of such grand-scale simulations could be multifaceted. Scientifically, they would provide unprecedented insights into the workings of galaxies, allowing researchers to model and study cosmic phenomena in extraordinary detail. From the formation of stars and black holes to the dynamics of galactic collisions, these simulations would offer a virtual laboratory for astrophysics, cosmology, and the study of extraterrestrial life. Beyond scientific research, galactic simulations could serve as testing grounds for interstellar exploration and large-scale engineering projects. Before traveling to a distant star system, humans could use these simulations to predict outcomes and refine strategies, thereby minimizing risks and maximizing efficiency. Moreover, these galactic simulations could potentially be used for educational and cultural purposes. They could offer virtual spaces where individuals can explore and experience different parts of the galaxy, learning about various celestial phenomena and the diversity of potential life forms and cultures within the galaxy. Number 11. Biological organisms could be created in minutes. This rapid creation of organisms would be made possible through advanced genetic engineering and nanotechnology. Scientists could have a complete understanding of the genetic code and the mechanisms of life at a molecular level. Using this knowledge, they could design and assemble DNA sequences with precision and speed, creating custom organisms tailored for specific purposes. The process would involve the use of highly sophisticated nanofabricators or bioprinters, capable of assembling organic molecules and cells into fully functional organisms. These machines would operate at an incredibly fast pace, arranging atoms and molecules with pinpoint accuracy to create complex biological structures in a matter of minutes. The applications of this technology would be vast and varied. For example, it could be used to create microorganisms designed to produce food, medicine, or energy. These organisms could be engineered to thrive in diverse environments, making them invaluable for space colonization and terraforming efforts. Moreover, this capability could lead to the development of entirely new forms of life, beyond what is found in nature. Scientists could design organisms with unique abilities or traits, potentially leading to breakthroughs in medicine, environmental remediation, and materials science. The ethical implications of such power would be significant. With the ability to create life so rapidly and easily, humanity would need to establish strict guidelines and ethical frameworks to govern the use of this technology. The potential impact on ecosystems, biodiversity, and the very definition of life would need to be carefully considered. Number 12. Planetary engineering could become commonplace. This advanced form of terraforming would involve the large-scale modification of planets to make them habitable or better suited for human use, leveraging the immense energy resources and technological capabilities at our disposal. One of the most fascinating aspects of planetary engineering would be the ability to alter entire planetary climates and ecosystems. For instance, on planets with inhospitable environments, we could manipulate atmospheric composition, temperature, and weather patterns to create Earth-like conditions. This could involve constructing massive orbital mirrors to regulate solar radiation and temperature. Beyond making planets habitable, planetary engineering could also be used to optimize planets for specific purposes. For example, a planet could be engineered to become a dedicated agricultural world, with ideal conditions for growing food to support human populations across the galaxy. Another planet might be transformed into a vast industrial complex, harnessing local resources. The ability to engineer planets would also open up possibilities for creating entirely new ecosystems and even experimenting with novel forms of life. Advanced genetic engineering could be used to develop plants and animals uniquely adapted to different planetary environments, potentially even creating new biospheres that are both sustainable and conducive to human life. We could even control the orbits of planets and moons using massive space-based structures, such as gravitational tractors or thrusters, which could exert precise forces on celestial bodies. This would allow us to adjust their orbits to more habitable zones around the Sun, where conditions are more suitable for life as we know it. This would significantly expand the habitable real estate within the solar system. Moreover, planetary engineering would not be limited to the physical transformation of planets. It could also involve the construction of massive artificial structures, such as space habitats or energy collectors that orbit the planets in our solar system. These structures could serve various functions, from housing populations to generating energy, further extending humanity's ability to utilize and inhabit space. Number 13. We could vaporize asteroids with the power of the Sun. This extraordinary capability would stem from our civilization's ability to capture and utilize a significant portion of the Sun's energy output. With this colossal energy at their disposal, humans could develop advanced directed energy weapons capable of focusing intense beams of energy toward distant targets, such as asteroids. These beams, potentially composed of high-energy particles or concentrated electromagnetic radiation, would be powerful enough to heat the material of an asteroid to the point of vaporization, effectively disintegrating it in space. The ability to vaporize asteroids would have significant practical applications, particularly in planetary defense. In the event of an asteroid on a collision course with Earth or any other inhabited world, this technology could be used to neutralize the threat from a safe distance, ensuring the safety of the planet. It could also be used in mining operations, where instead of physically mining an asteroid, the desired minerals could be vaporized and collected from the resulting cloud of material. Number 14. Matrioshka brains could provide unprecedented computational power throughout our solar system. Named after the Russian nesting dolls, Matrioshka brains are envisioned as a series of concentric Dyson spheres or shells in space, each capturing different wavelengths of the star's energy output for power. The primary purpose of Matrioshka brains would be to provide immense computational power, far beyond what we can currently imagine. Each layer of these structures would be dedicated to processing and data storage, utilizing the energy absorbed from the Sun. This setup would allow for staggeringly efficient energy use, as waste heat from one layer would be harnessed by the next, maximizing the energy extracted from the Sun. Matrioshka brains could could be used for a variety of purposes. They could simulate entire galaxies and even universes, allowing for unparalleled research into physics and cosmology. They could also host countless virtual worlds, providing realities as complex and diverse as our own for exploration, entertainment, or even digital immortality, where human consciousness could be uploaded and live within these simulations. The computational capabilities of Matrioshka brains would also be instrumental in solving complex scientific and mathematical problems, potentially unlocking mysteries of the universe that are currently beyond our grasp. They could process and analyze data from across the galaxy, aiding in the management and coordination of a civilization spread across multiple star systems. Moreover, Matrioshka brains could serve as central hubs for our civilization's knowledge and culture, preserving the collective wisdom of humanity and other sentient beings it might encounter. They could act as universal libraries and centers for learning, accessible to all members of our civilization. Number 15, quantum-based interstellar communication could be possible. The vast distances between stars, which pose a significant challenge for communication with our current technology, would be overcome through advanced methods and technologies. One of the most intriguing possibilities for interstellar communication would be the use of quantum entanglement. This phenomenon, which allows particles to instantaneously affect each other regardless of the distance separating them, could theoretically be harnessed to create communication channels that operate faster than light. This would enable real-time communication across vast interstellar distances, effectively eliminating the time lag that would otherwise be a major obstacle for maintaining contact between distant colonies. Interstellar communication would not only be about the transmission of data, it would also involve the translation and interpretation of diverse languages and codes used by different human colonies. Advanced AI algorithms could be employed to seamlessly translate and interpret these communications, ensuring that a diverse and widespread civilization remains interconnected and unified. Thanks for watching. Make sure to watch this next video about the future of humanity.